Alright, hey guys, we'll be going over the methods exam 1 that you guys did today. This is my first time doing it as well. I haven't done any reading time or whatever, so my explanations might be a little slower, but that's okay. Just please bear with me. Alright, question 1. Find dy dx, simple question, my pen out. So, simple use of product rule. So differentiating e to the x first, and then differentiating cos of 3x is negative 3 sine of 3x. So there we go. Find the derivative of x equals 3 when f of x equals this natural log. So finding the derivative using chain rule, it's simply just going to be the derivative of this over the cubic. So it's going to be 3x squared minus 3 over x cubed minus 3x plus 2. Substituting x equals 3 gives 27 minus 3 over 27 minus 9 plus 2, which is 24 over 20, which is 6 over 5. Next question. Determine the value of k for which the systems have no real solution. So what we're going to do here is we're going to rearrange both equations for y. So this one we get y equals to 3k on 2x minus k plus 4 on 2. And then this one we get y is equal to negative k minus 4 on kx minus 1. So if they have no solutions, first of all, the gradients need to be equal, but also the y-intercepts cannot be equal. So first let's do the gradients. So 3k on 2 is equal to negative k minus 4 on k. Cross multiply, we get 2k minus 8 is equal to 3k squared, negative 3k squared. So 3k squared plus 2k minus 8 is equal to 0. This is probably factorizable. 3k 4 and 2. Yep, so 6 plus negative 6 minus 4. Okay, yep. So minus 4k plus 2. Just double check. 3k squared plus 6k minus, yep, equals 0. So from here we get that k is equal to 4 on 3 or negative 2. However, we can't just leave that as our answer because we need to check whether these values of k make these two the same. So k plus 4 on 2 cannot equal 1. And as we substitute negative 2 into here, we'll get negative 2 plus 4, which is 2. 2 on 2 is equal to 1. Therefore, 2 is not a solution because, sorry, negative 2 is not a solution because that's when they will be the exact same graph and they'll have infinite solutions. So therefore, k equals 4 on 3 is the only solution. All right, question 3, let g of x equal to this graph. Sketch the graph. Okay, so immediately, zoom out a bit here. Immediately, x equals negative 3. So because x plus 3 squared, x can't equal negative 3. That is an asymptote. And then also y equals negative 2. Like this. And we do have to label them. So y is equal to negative 2, x is equal to negative 3. Then let's find the axial intercepts. So when x equals 0, we get 1 over 9 minus 18 over 9, which is negative 17 over 9, which is around here. 0, negative 17 over 9. Then the x-intercepts, we get, setting it equal to 0, we get 1 over x plus 3 is equal to plus or minus root 2. X plus 3 is equal to plus or minus root 2 on 2. So x is equal to plus or minus root 2 on 2 minus 3. So that's around here, I think. Root 2 on 2 minus 3, 0. Split arrow. Negative root 2 on 2 minus 3, 0. And drawing it in is just going to look something like this. Oops. Sorry, this is really hard to do on a Wacom tablet. Like that. So it should look something like this. It should be a reflection of each other over the graph of x equals negative 3. All right, now determine the area of the region bounded by the line x equals negative 2, x and y axis, and the graph. So if we draw a line at x equals negative 2, it wants us to find this area. So that area is equal to, since it's below the graph, we need to negative it, negative 2 to 0 of 1 over x plus 3 squared minus 2 dx. This gives us negative 1 over x plus 3 minus 2x from negative 2 to 0. And we can take out the negative to cancel this negative here, giving us 1 over x plus 3 plus 2x from negative 2 to 0. So substituting 0, we get 1 over 3, and then minus negative 2, we get, what's that? 1 over negative, no, just 1. And then plus, oh, not plus 4, minus 4. So we get 1 over 3 plus 3, essentially, which is equal to 10 on 3. Okay. Next, be a binomial random variable, 4 to 9 on 10. Find the standard deviation. Okay, so that's it, just using the formula, np1 minus p, which is equal to root 4 times 0.9 times 0.1. Square rooting the 4, we get 2, and then this is going to be 0.09, which is 2 times 0.3, which is 0.6. Find the probability that x is less than 2. Well, that's just going to be the probability that x equals 0. What's the probability that x equals 1? X equals 0 is going to be 1 over 10 to the power of 4. Probability that x equals 1 is going to be 4 times 9 on 10. 1 over 10 to the power of 3. Factoring out a 1 over 10 cubed, we get 1 over 1,000 is equal to 1 over 10 plus, it's going to be 36 on 10. So it's going to be 37 on 10, 37 on 10,000, which is equal to 0.004037. All right, function h of t is equal to 3,000 over t plus 1 models the population after t years. Use the model h of t to predict the population of the town after 4 years. All right, so t equals 4. 3,000 over 5 is going to be 600 people. A new function h of 1 models a population where the initial value is the same, so initial value is 3,000, but h of 1 decreases at half the rate of h at any point in time. So what does this mean? It means that h1 of t is equal to half of h of t. And h of t, derivative of t is going to be negative 3,000 over t plus 1 squared times a half. So it's going to be negative 1,500 t plus 1 squared. And then integrating, we get that h of t must equal to 1,500 over t plus 1 plus c. And since we have this, it means that c must equal 1,500 in order to make the initial value equal to 3,000. So to get from h of t to this graph, first we need to dilate by factor, let's see here, half to essentially, cut it half from t-axis, and then translate 1,500 units up. Let me just double check because I'm not really good with my transformations. Yeah, should be right. Okay, those are your two transformations there. In the town, 100 people were randomly selected with 60 people indicating that they were unhappy. Determine a 95% confidence interval using z equals 2. So the 95% confidence interval is equal to this minus 2 this, and this plus 2 this. The mean is equal to 0.6, and the standard deviation is equal to the square root of 0.6 times 0.4 on 100, which is equal to root 0.24 on 100, which is equal to root 24 on 1,000, no, 10,000, which is equal to 2 root 6 on 100, which is root 6 on 50. Okay, so now we have 0.6 minus, so multiplying this by 2 gives root 6 on 25. And I guess we can simplify it. So this is equal to 3 on 5. So it's going to be 15 minus root 6 on 25. 15 plus root 6 on 25. A new sample of n people results in the same sample proportion. Find the smallest value of n to achieve a standard deviation of root 2 on 50. So just solving the equation here. Root 24 on n is equal to root 2 on 50. So this gives, let's just square both sides, 0.24 on n is equal to 2 on 2,500, which is 1 over 1,250. And then what do we have here? We have 24 over 100. 24 over 100 n is equal to 12 over 50, 6 over 25. And so 6 is equal to 25n on 1,250. This is gonna be 1,250 divided by 25 is 50, I think. So n is equal to 300, 50 times 60. All right. Solve this equation now. So to do this, we're just going to combine all the logs. So we get log 3 of x minus 4 squared is equal to 2. And then 3 to the power of both sides gives x squared minus 8x plus 16 is equal to 9. So x cubed minus 8x squared plus 16x minus 9 is equal to 0. And to find this, we need to substitute values of, or factors of 9 to see which ones work. So when we substitute 1, oh wait, 1 works. 1 minus 9, does it? 1 minus 8, I think it does. Yeah, oh, 1 works, right. X minus 1, x cubed minus 8x squared plus 16x minus 9, x squared, x cubed minus x squared, negative 7x squared plus 16x minus 7x. Well, then it has to be plus 9 at the end. So this gives x minus 1, x squared minus 7x plus 9 is equal to 0. But when we substitute, if x equals 1 was a solution, it wouldn't actually work, because when we substitute x equals 1 into here, it's going to be a negative number. You can't take the log of a negative number. Therefore, it's just x squared minus 7x plus 9 is equal to 0. And I'm pretty sure that can't be factorized, so x is equal to 7 plus or minus 49 minus 36 root 13 on 2. Now, these don't seem to be negative, okay, because 7 is root 49. That's obviously greater than root 13. But is it going to satisfy this part? So essentially, both of these numbers have to be greater than 4. Okay, well, this is equal to 7 on 2 minus root 13 on 2, or plus or minus. And 7 on 2 is 3.5, so if you minus something from that, obviously it's going to be less than 4. So the negative version is less than 4, therefore only the positive version should be counted as a solution. Nice. Right, part of the graph of x sine of x is shown below. Use a trapezium rule with a step size of pi on 3 to approximate the area between 0 and pi. Alright, so boom, boom. It's going to be half height a plus b. The height is pi on 3, so it's going to be pi on 6a plus b. So it's going to be pi on 6. First one is going to be f of 0, which is just 0, so we can ignore that. And then b is going to be f of pi on 3. Plus pi on 6. The next one is going to be f of pi on 3 plus f of 2 pi on 3. Last one is going to be pi on 6, f of 2 pi on 3, and f of pi, which is also 0, so we can ignore that. Right, f of pi on 3, what is that? That's going to be pi on 3. Sine of pi on 3 is root 3 on 2. Root 3 pi on 6. Pi on 6. Root 3 pi on 6. Plus root 3 pi on 6. So we're just factoring out a pi on 6 from everything. F of 2 pi on 3 is just going to be double that. So plus root 3 pi on 3 plus root 3 pi on 3. Alright, what does this give us? So this is going to be 2 on 6, 2 on 6, 4 on 6, 5 on 6, 6 on 6. So it's just going to be pi on 6 root 3 pi, which is equal to root 3 pi squared on 6 units squared. Great. Alright, and find the derivative. That's just easy. F of x is equal to sine of x plus x cos of x. Easy. Determine the range of, determine the range of the derivative of f of x over the interval of pi on 2 to pi on 3. Interesting. So pi on 2 is around, well, actually just half of pi, so right there. And as you can see, from here to here, the gradient is, the gradient is at its maximum over here. And then it decreases, 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 decreases until it's 0. And I don't know if it's a 0 at 2 pi on 3. It looks like it, but it could be a little more to the right. 2 pi on 3. And then maybe it becomes negative at 2 pi on 3. So, nevertheless, the minimum of the f of x occurs at 2 pi on 3. and the maximum occurs at pi of 2. So this is going to be sine of 2 pi on 3. Let me just write that down. Root 3 on 2 plus 2 pi on 3 negative a half minus plus, so root 3 on 2 minus pi on 3. Okay. Root 3 on 2 minus pi on 3, and then f of pi on 2 is 1, I think, right? Because that cancels out. Yeah, 1. Boom. Hence verify that f of x has a stationary point in this range. Okay. So all we have to do here is we have to realize that since sine of pi on 3 wasn't the stationary point, that means that this value here, root 3 on 2 minus pi on 3, must be negative. So since root 3 on 2 minus pi on 3 is less than 0, there exists there exists a such that f of a is equal to 0. And this is because f of x is strictly decreasing over that interval, over this interval. Cool. On the axis below, sketch the graph of the derivative. Okay. What do we have here? Negative 1.1 is a minimum. That's around there. And 1.1, 1.4. Okay. So, we must have a x-intercept here, an x-intercept here, and an x-intercept here, because that's where the turning points are. So it's going to look something like this. Presumably. Like that. Horrible. But looks kind of like a sine graph. And do we have to label anything? The endpoints. Okay. So negative pi, substitute that in, we get cancels negative pi. And then over here it's going to be the opposite. Okay, last question. Wait, is it the last question? It's only question 8. Oh, wow. Okay, cool. Let g of x equal this cubic, not cubic, the inverse of cubic. And let p be the y-intercept. Okay, so just substitute x equals 0, p is 0, cube root of negative k plus m. Find the gradient of g at p in terms of k. So g of x is equal to 1 over 3 x minus k to the power of negative 2 on 3, or 1 over 3x minus k to the power of 2 on 3. So at g, x equals 0, so this is going to be 1 over 3 to the power of negative k, 3 negative k to the power of 2 on 3. Boom. Given that the graph of y equals g of x passes through the origin, express k in terms of m. Right? So cube root of x minus k plus m is equal to 0. 0. And that means that cube root of negative k is equal to negative m. Negative k is equal to negative m cubed. K is equal to m cubed. Let the point Q be a point different from the point P, such that the gradient of G at the points P and Q are equal. Find Q. All right. So g of x now equals the cube root of x minus m cubed plus m, just substituting k equals m cubed. Differentiating that, we get 1 over 3 x minus m cubed to the power of negative 2 and 3. And this has to equal, as we found in b, this value. So 1 over 3 negative m cubed to the power of 2 and 3, which is equal to 1 over 3, that cancels, negative m squared, 3m squared. Alright, so solving for x, that is equal, those two cancel, and we get that x minus m cubed to the power of 2 on 3 is equal to m squared. And then raise both sides to the power of 3 on 2. We get that x is equal to x minus m cubed is equal to, oh, m cubed. So x is equal to 2m cubed. And when we substitute that back into g of x, we get g of 2m cubed is equal to cube root of 2m cubed minus m cubed plus m cube root of m cubed plus m, so 2m. 2m cubed, 2m. What is it? 2m. Therefore, q is the coordinate 2m cubed, 2m. Boom. And that's exam 1. Pretty good exam. I'd say it's more difficult or less difficult than last year. Can I remember the last year questions? I'd say it's maybe a little tiny more difficult than last year. But yeah, pretty good exam. Exam 2 solutions will be out tomorrow. Yeah, see you later.